Hi, Wheat North. Today we're going to talk about IMFs and evaporation rate. So how does the rate of evaporation relate to IMFs? Okay, so big time middle school review here. What the heck is evaporation? It's water turning from a liquid into a gas. So you guys remember back from middle school our water cycle, and that was the process you learned when we have lakes or oceans and that liquid water turns into a gas. That's what we call evaporation. Okay. So how this really works is molecules on the surface of a liquid can escape these IMFs if they have enough kinetic energy. So let's just remember back when we're talking about these IMFs that all of these molecules are attracted to one another. So especially for water, it has that hydrogen bonding, it kind of wants to stick together. But if our molecules have enough kinetic energy, they're able to escape. Now, what is kinetic energy? Kinetic energy is just the energy of motion. So if there's a molecule that is moving around at a faster rate, it has more energy, it's going to be able to break away from those IMFs to change from a liquid state into a gas state. Okay, and if it's lower energy, it's going to remain then as a liquid. So here's a couple of analogies for you. So if anyone's been tubing before, you know, these people are going along here and they're bouncing around, and this guy right here, he has enough kinetic energy that he gets launched off of the tube. The same thing here from Charlie Brown's Christmas, right? The beginning opening scene, they're all ice skating, holding hands together, and then finally they get enough kinetic energy, in this case it was everybody, that they all went launching away from Snoopy because they had enough kinetic energy. Okay, now when we're talking about a liquid, okay, there's a few things that can affect the rate of this evaporation. Okay, so you know, if you heat something up, if there's wind or air flowing over the top of it, if there is a big surface area or the humidity above it, those are all going to impact the evaporation rate. And here's what's going on. Remember, those IMFs are those attractions in between molecules. Is if you have low IMFs, that essentially means that the molecule that weak attraction with low IMFs, they're not going to be able to stay together quite as much. So these factors will have an easier time in aiding evaporation or preventing it from happening. So if you heat it up, that's going to add kinetic energy to those molecules on the top and allow them to escape. Wind blowing, okay, so air flowing, air molecules going over the top, that's going to provide kinetic energy to the top of the liquid that'll allow those guys to escape. The more surface area you have, that means that there's just going to be a greater amount of exposure for those molecules to gain kinetic energy and then escape. And the last one's humidity. So if you have low humidity, meaning less water vapor in the air above the liquid, it provides more of an opportunity, or you can think of it as like open space, that those molecules are able to escape out. Okay, but it always will come down to the IMFs. If it's strong IMFs, it's going to resist, and they're not going to be able to escape. If it's low or weak IMFs, they're going to be able to escape more quickly or easily. All right, so this whole process then cools the liquid down. So evaporation is a cooling process. So all temperature is, it's just a measure of the average kinetic energy. So if this, in this picture we have over on the side here, this animation is, just imagine it as a cup of water. Okay. Now in that cup of water there's all of these molecules, right, moving around. Now some of them are going to have lower kinetic energy. That's going to be like your blue ones that are moving real slowly. And some of them are going to have high kinetic energy. Okay, so being the red ones zipping around real quick here. So temperature is just an average of all of these guys together. Okay, and that's what the temperature is telling us. Only the fastest or the hottest are going to be able to escape the IMFs. And if you have ones that are moving slower, the IMFs are going to be able to hold those molecules within the liquid. Okay, so those fast-moving ones are going to be the ones that have enough energy then to finally escape. Okay, so to kind of demonstrate that process, what I have here is some water. Okay, can you see by our fancy diagram up here? So this would be your cup full of water. Now within here we've got, because the surface is exposed to light, the surface is exposed to that wind blowing along, these molecules of water along the top are going to have more kinetic energy. They're going to be moving around a lot faster than these other guys, and I've signified the kinetic energy by making these guys red. These down here, they are not exposed to that wind. They're not exposed to that temperature, higher temperature up on the surface here. They're not exposed to that wind, so they have a lower kinetic energy. Okay, so what happens then, why is evaporation a cooling process, or how does it cool the liquid? So you have your liquid here, okay, and let's just imagine that you get out of the swimming pool in the summertime, right? Everyone's experienced this, and you get out of the pool and you feel cold. Well, why is that? Well, when you go out, your skin then is exposed to the air, the wind blowing around, and those hot molecules, they're zipping around, and because they have a higher kinetic energy, they are going to evaporate away. Okay, and when they evaporate away, that leaves behind these molecules that have a lower kinetic energy. So because those quote-unquote hot molecules have left, you are then left the lower kinetic energy, the cold molecules are left behind, and that's why you feel a chill. And this is also what you guys felt on your skin when we put the alcohol on your skin, and you felt that it had a cool feeling compared to the water. Okay, so how is evaporation different than boiling? So we've just talked about evaporation, but you guys know what boiling is. So what's the difference between those two things? Let's look at them. Evaporation can happen at any temperature. Okay, so it doesn't necessarily have to be hot or cold. Evaporation can happen at any temperature. When we talk about boiling, we're talking about the liquid is being heated. And boiling happens at a specific boiling point. Okay, so that's a big difference. Evaporation is non-heated. Boiling is when we're going to be applying heat to the system. Okay, in evaporation, only the surface molecules can vaporize. That's again because of the reason what we talked about was the fact that those molecules that are at the surface, they're the ones that are going to be exposed to the wind and the sunshine and the humidity of the air. Okay, so for boiling, the molecules throughout the liquid are going to vaporize. So it's not just the surface, it's throughout the whole system. For evaporation, the overall temperature of the liquid gets colder as evaporation occurs, and that's for the reason we just talked about, right? Those hot molecules leaving the cold ones behind. And in boiling, the overall temperature of the liquid is maintained as boiling occurs. So as you boil water, it's going to get to 100 degrees Celsius, and it's going to stay at 100 degrees Celsius. Even though those water molecules are leaving the system, the overall temperature of the liquid is going to stay the same. Okay. All right. Now, what we're going to do here is, a lab that's going to have us measure and check the difference between evaporation rate and how that's impacted. So, we did something similar to this with the thermometers and the alcohol, and you're seeing how some substances evaporate quickly, some evaporate slowly, and that impacts the overall temperature. And remember, it always comes back to IMFs. If something's evaporating quickly, it's doing that because it has weak IMFs. If something evaporates slowly, it's because it has strong IMFs. Okay? If you guys have any questions, stop the video, rewind it, rewatch portions of it, and then make sure you touch base with your teacher.